So things that I have found that make this a little more complicated in my brain anyway, it took me a little while to get used to it, is every time you have an imaginary, remember they always travel in pairs. And sometimes they notate it. There is no like consistent notation. So sometimes they write it like this one where they have your square root with a positive and a negative, because every time you take the square root of a number, you have a positive and a negative version of it. So it does happen twice, and sometimes they write them out twice. And then other times they do not. So just always remember imaginary numbers or roots, radical forms are going to always have a double, whether it's written twice or not. There's always a positive and a negative. So if we were to write this out, our actual roots would be 4. It's plus minus, so it would be plus I and then a negative I. It does take care of itself. Depending on who you watch, if you go Google something else or you watch another YouTube video or possibly on an ed puzzle along the way, they will also write this as plus minus I, because when you square a negative number, it becomes positive. If you square a positive number, it becomes positive. So negative 2 squared is positive 4. Positive 2 squared is positive 4. So they actually end up with the same answer, but just reminding yourself that imaginary solutions do happen twice. So when you're done with this, though there's only 2 things in this list, this polynomial should be to the 3rd power. So 1, 2, 3 when we're done. A lot of people did not hear me out when I said it's easier to do this. We just wrote our factor as x plus 4 because, it's opposite of 4. And I do it too. I'm the worst at doing it because it saves you some thought and some writing. But when you get into the complex and the rationals and the imaginaries, you kind of have to do it. Maybe if you did enough, which is not likely, and you write them all down, you could learn the pattern to not have to write it all the way out. But x equals, and I'm going to write it once because, again, if I square a number, it's going to get rid of the positive and the negative, and it's going to be exactly the same. Also, a reminder, I is the square root of negative 1 every time. So it's just like pi. It's like the e for logs and exponentials. They are numbers. It is a number. I is not just a variable. It is a number. So if that means this is the same thing as writing x equals plus minus the square root of negative 1. To get it set equal to 0, I did watch a couple videos where they just moved this bugger over. I do not think that's a great idea, personally, because then you have to fix it afterwards. You want things in the most simplest form. So to get rid of a square root bar, the inverse operation is squaring. So we're going to square both sides. So then I end up with x squared, and that just gets rid of the root bar because the square root of negative 1 times the square root of negative 1 is going to be the square root. These guys get rid of each other, and that's how you end up with that negative 1 there. So it is going to be, and it's squared, so it's going to be 1. I'm sorry, negative 1. I was right. I'm talking myself out of this. So it's going to be that negative 1. And then we need to get it set equal to 0. So we're going to add 1 to both sides. X squared plus 1 equals 0. So now we have our 2 factors. The x squared is why that happens, like when we talk about it coming in pairs. So that's a factor and that's a factor. To write the equation in factored form, you would just write those 2 things on the same line, and it would be in factored form. More times than not, you're going to see this answer in standard form. So we're going to have to multiply those together. I'm going to do box method just because it keeps me accountable with all the numbers. You could also do FOIL, or if you want to call it distributive property, that's fine. And that's at x plus 4. I did have a lot of questions last week from different classes, but just across the board. You're writing your binomial on one side and then the other binomial on the other side. So this comes from this set of parentheses and the vertical comes from the other set of parentheses. X times x squared, it's going to give me x cubed. 1 times x is going to give me 1x, which is also just x. 4 times x squared gives me 4x squared. And last but not least, both of the last terms. So this is FOIL as well. So we did our first, our outer, our inner, and our last is going to be 4 times 1, which is 4. Now we're going to pull out. There was a video I watched last week maybe, or this week, and they put in a placeholder because this is 2, we're missing the 1, none. Kind of like when they did in synthetic division, which keeps your numbers matching up on the diagonal like you would have done in Math 1, multiplying probably with the box method. But the idea is that the x to the third is going to be your highest exponent. X squared, there's not another x squared. So we're going to write him second. Then we have x to the 1 power, or just x. And then our constant. And so that would be your final answer that has the roots or solutions at -4 and I, an imaginary one. Now, what I wanted to try, and I did not get to do it this morning before we got together because things kind of just kept going. I am pretty sure if we type in y equals x plus 4, and then, I'm not sure, I've never tried I before, so we're going to try it. Probably is not going to get us there. We're going to go from different points and see how much math we actually have to do. So x squared, so you would have to know that part. So plus 1. Those are our factored form. And then our answer, x to the third. And this would be beneficial in the event it happened to be a multiple choice question. You could do the math or you could not do the math because they should and they do. So we did do it correctly. Graph on top of each other. What I'm not sure is if I do x, I don't think it is going to work because it's going to do points. I don't know. Let's try it. X equals -4. And x equals I. That does not help us at all. Let's see if I can put in a plus minus. I don't know if that's even an option. It's not, sadly. Let's see if we added x equals a -I to see if there's even a pattern. There's not. Oh well, that didn't help us at all. So I was making sure there wasn't another hack or something easier for us to do. You would have to be able to get it into factored form, but you could get out of having to multiply them out if it was multiple choice. Or you can definitely do this to make sure you don't pick the wrong answer and don't put the wrong answer in. So maybe catch a mistake somewhere silly along the way. So it's not maybe as helpful as I thought it could have been. Okay, so square root. Like I said, I is a square root as well, so it's basically the same thing. We're going to do x equals a -3. We're going to add 3 to both sides because that's how we would get that -3 over to the other side. So we have x plus 3. So we do know that this graph is going to cross at a -3 when we graph it. These are the plus minus. They just listed them out, but we'll do them both just for conversation's sake. So x equals the square root of 3, and x equals -1 times the square root of 3, or a negative square root of 3. I want to get rid of the square root before I move it and attach it to anything else. So again, the inverse operation of square rooting something is squaring it. That is not multiplying by 2. That is squaring it. So multiplying by itself. So that's going to give me x squared equals a +3 because that just takes away the root bar. So we're going to subtract 3 from both sides because he's positive. So I'm going to get x squared minus 3 equals 0, or just x squared minus 3 because we're looking for our factors. Same thing here. We're going to square both sides. And that square is going to hit both of these. That's -1 squared gives me a positive squared. And then squaring the square root just makes it go away. So I end up with x squared equals 3 again. Sorry, I didn't put my squared there. No need to keep going. It's the exact same thing, so you don't have to do it twice. The same thing is the same thing. So this one, again, we have 1, 2, 3 roots. This would be our 1x. This would be x squared. So we're going to end up with an x to the third power polynomial when we multiply it together. So if you're a FOIL person, we're going to multiply these together. So first would be x times x squared, which would be that first box, typically if we're doing it in box method. And that's going to give me x to the third. Then we're going to do x times a negative 3, which is if you were working straight down, depending, or straight across the top, depending on what order you wrote it in. Just give me a negative 3x. And then we do 3 times x squared plus 3x squared. That one's kind of hard to read. Sorry. Toss that pen and not use that one anymore. It's a positive. And then last but not least is 3 times a negative 3. Just give us a negative 9. You do want to make sure it's always in standard form. Always, always in standard form. So highest exponent, the next. So counting down in exponents. So that's going to be x to the third because that is our highest. Took care of that one. X squared is next. That's a positive 3x squared. Took care of that one. X to the 1. And then our constant. And then we have our answer. And again, you could go plug in your 2 factors. Excuse me. Oh, sorry. Woo. Then plug in your 2 factors and then your answer, and they should graph on top of each other. All right, so when they get a little extra wonky is down here. So both of these are obviously exactly the same, just different numbers, so the process would be the same. We are going to, we know that we have 1, so x equals 1. We're going to subtract 1 from both sides. And that factor is going to be that x minus 1. So we got first factor. And then I have minus 2 plus the square root of 6. Again, as soon as you square root, we know there's 2 of them. That negative 2 does not change. The square root of 6 operation in front of it does. There's always the plus minus. If they give you the plus, you're missing the minus. Again, there is no pattern consistently as to whether they're going to list them like number 2 we just did where they had the positive and the negative, or if they just give you 1 and you have to remember that there is a positive and a negative. So if we set those equal to x, we want to move, because ideally we need to get rid of our square root. We want to move that negative 2 first, so we're going to add 2 to both sides. And so we're going to have x plus 2 equals the square root of 6. Same thing for the other one. X plus 2 equals a negative square root of 6. And we're going to square both sides to get rid of the root. And in this case, remember, that's like a negative 1 in the front. So it gets rid of the root and it gets rid of the negative, because the negative 1 times the negative 1 is a positive 1. So then we end up with just 6. So we have x plus 2 squared equals 6. And again, x plus 2 squared equals 6. So we are done with this guy because it's already going to exist in the next one. X plus 2 squared. I did see some teachers, again, looking at other videos, just always watching to see if someone teaches something better than me, where they moved the square root of 6 early, or they moved the 6 now. I do not think that's a great idea, personally. I think you should multiply this out. So we're going to get a quadratic with a constant, and then we'll get it set equal to 0. So again, you can use box, or you can use your FOIL. So x plus 2, x plus 2. And x times x is x squared. X times 2 is 2x. X times 2 is 2x. 2 times 2 is going to be 4. So then I end up with x squared plus 4x plus 4 equals 6. It's not a factor yet because it's not set equal to 0. So we're going to move this 6 over by subtracting 6 from both sides to get our constants together. And now I have my next factor. So my factor is big. It's a quadratic this time. And then we have our binomial x minus 1. Again, you're just going to multiply these together to get your final answer. This time, I think box is the best because it's easy to miss things when it gets more than a binomial because we've done more of the FOIL style binomial distribution. If you want to do distribution, just make sure you don't leave anyone out. Everyone gets candy when you're doing distribution. If you're in a classroom and somebody gets left out, it's wrong, they're upset, all the things. So x times x squared, x to the third power. X times 4x is going to be 4x squared. X times a negative 2 is a negative 2x. X squared times a negative 1 is going to be a negative 1x squared. 4x times a negative 1 is a negative 4x. Negative 2 times a negative 1 is a positive 2. And then again, we got to clean up to write our final answer in standard form. Highest exponent first, which is going to be x cubed. And that makes sense because I had 1, 2, 3 roots by the time we were done with it. We had an x in our first one and an x squared in the second one, so we're doing good there. Combine our x squareds. So 4 plus a negative 1 or minus 1 is going to give me plus 3x squared. Negative 4 and negative 2, negative 6x. And then last but not least, that constant 2. So number 3 should be x cubed plus 3x squared minus 6x plus 2. And again, you could put your factored form into your L1, like your first one in Desmos, and the second, like your answer in Desmos, to double check that it worked. I am going to probably skip number 4 because it's exactly like number 3. And I'm going to go to number 5, just for sake of time. Number 5 looks pretty wild and scary. It only has 2, but your keys would be that you see an I and you see the square root. This is not 2 plus the square root of 2. It's 2 times the square root of 2, which does change things just a hair. So we're going to set it equal to x equals a negative 3 plus 2i. We need I by itself because we're going to square it. You could square the whole thing as well. I would not yet. I would move this negative 3. So x minus 3, plus 3, I'm sorry, equals 2i. And then I would square it now. I would not necessarily divide by 2 because that's going to make a mess. Division is not fun. So we're going to square it. And we're going to hold our breath and hope I'm doing this one right. So then this again is going to become x plus 3 times x plus 3. This is going to go to our 2. So 2 squared is going to be 4. And 2 times the square root of negative 1 is going to be the negative 1. So it's going to be negative 4. This is going to be x squared, and I'm cheating a little bit just to get us past it. And then, sorry, I just looked up and realized something was wrong. So it's going to be 6x, I'm sorry, not 9x. 6x plus 9. We're going to add 4 over, so that's going to be x squared plus 6x plus 15. Then we're going to do the same thing, so that's our first factor. So x equals 2 times the square root of 2. The 2 times, you could divide by 2, but then you're squaring fractions. I would not do that there. Again, we're trying to get rid of our square root, so we're going to square both sides. And that's going to give me x squared equals 2 squared, which is 4, times, we're going to get rid of that, times 2. So that's going to give me x squared equals 8. We're going to subtract 8 from both sides. So x squared minus 8 is our factor. Now we have those 2 factors, and you're going to multiply those together. So I'm going to pause for a second and give you a minute to multiply those. X to the 4th, negative 8x squared, 6x to the 3rd. 8 times 6 is going to be 48. Now I'm questioning everything I do. Yep, 48. X is negative 15x squared. 8 times 15 is going to be a negative 120. So we're going to clean that up. That shouldn't be a 15, that should be a 13. 9 and 4 are 13. 13. And this should give me 13 times 8, 104. All right, so we clean that up. We end up with x to the 4th. There's an x to the 3rd that's not on the diagonal. So plus 6x to the 3rd. We got an x squared and an x squared. And that's what I meant by, like, if you put your space holders in, they would be matched on the diagonal, not kind of slid. Because this one you're missing the x to the 1 power. So it would just be 0x 1. We do end up with the 7x squared plus 48x minus 104. That 15x does not 15. I didn't change it all the way through. I'm sorry. That's a 13. So it'll be 5x, not 7. Woo! And we are correct on that one. So number 6 is the same idea again, except there's just not a 2, it's a 1. And they wrote it twice. You can do it twice, but you end up with the same factor again. That's where you end up with that x squared. I have watched teachers make people do it twice. But then I've also watched students, when they did it twice and end up with the same factor twice, you use it twice and multiply it twice. That you do not do. So in my brain, it makes sense to do it once. So we could just do plus minus. I'm going to move the 3 because I don't want to necessarily square it here because it's attached by plus minus. And we don't want to end up with an I. The goal is to get rid of an I. So that's going to be x minus 3 equals plus minus I. And that's the square root of a negative 1. So we're going to square both sides. Which is going to make this all turn into a negative 1. We're going to do x minus 3 times x minus 3. So you can FOIL or box again, whatever you want to do. But that's going to give us x squared minus 6x plus 9 equals a negative 1. We're going to move the 1 over. So that's going to be x squared minus 6x, add 1. So that's your 10. And I got that 6 because of the negative 3x, negative 3x. If they match like this, ultimately you multiply x squared. Then whatever this is with an x plus, we add these, gives you the middle, and then multiply the last is another way to do it if you don't want to write out the math all the way through. If you're to that point where you understand the multiplication of binomials pretty clearly, that does not work for anything that's not a binomial. So we're going to do the same thing for the other one. X equals 2 plus 2 square roots of 2. We're going to move the 2 that's in the front that's attached by addition. So that's going to be x minus 2 equals 2 square roots of 2. That is attached by multiplication. So we're going to square both sides because we don't want to divide because that would be a mess. So I end up with x minus 2 times x minus 2. That's going to hit that x, and it's going to hit there. Hit that 2. So 2 squared is going to give me 4, and then that's going to be times 2, so we're going to have an 8. And again, so we have x squared. Negative 2 plus a negative 2 is going to be negative 4x. Negative 2 times negative 2 is going to be a positive 4. Going to move the 8 over. You would subtract it because that's the inverse. That's going to give me that minus 4 equals 0. So now I have 2 quadratic factors to multiply together. Again, I personally would do box method because you will skip something, especially if you're nervous on test day or you're sitting at home and you have lots of things going on in your house. It's too easy to skip a number. So again, your trinomial goes on one side, and then your other trinomial goes on the other side. And then we're just going to work into our box. So x squared times x squared is going to be x to the 4th. I'm going to work straight down. Negative 4x times x squared is going to be negative 4x to the 3rd because there's 2 and 1. Then negative 4x squared. Negative 6x times x squared is going to give you a negative 6x to the 3rd. Negative 6 times a negative 4 is going to give me that positive 24. X times x gives me x squared. Negative 6 times negative 4 again is going to be the positive 24 with only one x from the top. 10x squared, because 10 times x squared. 10 times a negative 4 is a negative 40x. And then 10 times a negative 4 is going to be negative 40 without an x at this point. So at that point, we're going to now clean up. Everybody was present, so 2, 1, none, 2, 1, none. So they should work on the diagonals. X to the 4th is going to be your highest exponent. Then we have a negative 4 and a negative 6. So it's going to be negative 10x cubed. I take 4 away. I have 24 and I have 10. I would go ahead and take that 4 away here, and then I have 20 and I have 10. So that's 30x squared. I have 24. I lost 40. So I'm going to owe somebody 16. And then last but not least, our negative 40 constant. So I would say the biggest thing would be don't talk yourself out of answers, because you know inverse operations. Do not square when there's an I, the entire thing. Try to get I down to as simple as possible. Or your square root even, like number 6, that 2 plus 2 square roots of 2. Get it down as easy as possible. Or as small as possible. Then square it. So that way you get rid of your I's and you get rid of your root bars without making a hot mess of everything and having to do more FOIL and more box than necessary.